This presentation focuses on intercept multi-level regression. The purpose of multi-level regression is to remove patient effects in comparison of practice or hospital performances. Multi-level analysis is done at least two levels. In the micro level, patient characteristics and outcomes are related. Then average outcome for the practice in situations where no patient characteristics are present are shared with macro-level analysis. The macro-level analysis focuses on practice-level changes and what is associated with changes in practice patterns. We begin with showing how multi-level analysis is done with two separate regressions. We focus on intercept regressions. An intercept model can be described with two equations. The first focuses on micro-level relationships for the outcome and R patient characteristics x1 through xr. This equation, Yij, is the outcome of the ith patient in the jth practice. Beta 0j is the overall constant or intercept for each practice. Variables beta 1 through beta r describe the estimated parameters for patient characteristics. The intercept of this model is the only term that is not multiplied by any patient characteristics and hence is known as the average impact on outcome when all patient characteristics are absent. Note that beta 1 x1 through beta r xr are the total effects of patient-level characteristics on practice outcomes. Ignoring these parameters de facto evaluates the equation where all patient characteristics are at zero level, or in other words, absent. The regression has gone ahead and estimated these parameters, but these are of no use in subsequent macro-level analysis, as the macro level compares all practices when patient characteristics are all absent. In this regression, all variables are measured across all patients in all practices. Hence, the index I and j indicate that data are for patient I in practice j. If the relationship between outcomes and patient features is not linear, a non-linear model must be fitted. The macro or practice level regression examines variations in the calculated average outcome at each practice. We want to explain these variations as a function of Q practice level features Z1 through ZQ as shown in the equation. Here, beta 0j is the average outcome after removing the impact of individual characteristics. It comes from micro-level intercepts. Y0 is the average value of the outcome across all practices. Y1 through Yr are the parameters estimated for practice-level features. If the relationship between practice features and outcome are nonlinear, then a nonlinear model must be examined. Let us look at actual data. We start with a regression with patient-level data across all hospitals. We show here the result of the micro-level regression. The independent variables include severe burn, head injury, age, and gender. These are patient characteristics. We want to remove the effect of variation in these characteristics. The equation also includes several intercepts. It starts with an overall constant of 0, which is irrelevant, as we have estimated the intercept for each hospital by dummy variables. Hospital A has an intercept of 102, Hospital B of 124, Hospital C through E intercepts are also given. These intercepts are the average outcomes at the hospital for young male patients without severe burn and without head injury. In effect, we have removed the variations in outcomes due to patient-level data, by focusing on situations where all patient-level data are absent. This table shows the results for macro-level analysis. The dependent variable shows the intercept calculated in micro-level regression. These are calculated average odds of survival at each hospital when variations due to patient characteristics are statistically removed. Independent variables are whether the hospital has been designated as tertiary center and whether the hospital has a burn unit. Regressing the odds of survival on the independent variables will help us understand the effect of burn unit and tertiary designation on survival, while statistically controlling for patient case mix differences. Inside electronic health records, it's difficult to do regressions. An alternative to multi-level regression is multi-level stratification. First, we calculate outcomes for Hospital A in different strata of patient characteristics. Then we calculate the outcomes for other hospitals. We stratify the same 4 variables and count survival in other hospitals. Then we merge the 2 files matching outcomes on same strata. The inner join is our patient characteristics that define the strata in previous 2 steps. This table shows the results of the SQL code up to this point. We have survival rates for Hospital A and other hospitals. For example, for male patients with no other problems, 99% survive in Hospital A, while 95% survive in other hospitals. These survival rates are affected by patient characteristics. As the matched strata indicate, more severe conditions, survivals decline. This step ends the step equivalent to micro-regression. In step 2, we examine the performance of hospitals after removing patient characteristics. To understand this step, we have displayed the data so far. The x-axis lists the strata. The strata are nominal scales composed of various combinations of patient characteristics. For example, one strata is called male, another is called head injury 65 plus and male. We can put these strata on x-axis in any order. As we will see shortly, it is best to order the strata using overall survival rate. We have arranged these strata so that later strata have lower survival rates than earlier strata. You can see this in the graph. The blue line is nearly straight. This is because we switched the strata around until we got a nearly straight line. Any other order of the strata would produce a more jagged line. This ordering of the strata creates an implicit index. The arrangement in order captures the overall severity of the patient's illness. Later strata indicate sicker patients. Since this order has been created, we can now talk of patients who have no indicators of any sickness. These are the patients who have none of the characteristics in the strata, and because we have ordered these strata, then these patients fall on the y-axis. In other words, they would be the intercept of the line. Notice also that comparing the 2 lines tells us net impact of Hospital A. Notice how for some strata, the difference is small, and in others, the difference is large. When patients have no severe conditions, for example, the male strata, the difference is small. The sicker the patient gets, the differences get larger. This phenomenon is also due to the fact that we have arranged the strata in order of severity of sickness. For the macro-level analysis, we need an estimated intercept when no patient characteristics are present. This can be estimated by regressing survival in Hospital A on survival in other hospitals across the various strata. The predicted values in this regression reflect the effect of the strata, or in other words, the effect of patient's case mix. The intercept shows the effect of hospital A, but none of the effects of the strata. Thus, the intercept is a measure of survival when all patient features are absent. In the SQL code, the intercept of the macro-level regression can be calculated without relying on any statistical package. If X is the survival at other hospital and Y is the survival at hospital A, then the regression line is Y equals alpha plus beta times X. The parameters alpha and beta in this equation can be estimated from these two formulas. In these two equations, Y bar is the average survival at hospital A and X bar is the average survival at other hospitals. The take-home message is that whether we do regression or use SQL, multi-level analysis examines practice differences when patient-level differences do not exist.